Apparently, we're live now, so good morning, afternoon, or evening, wherever you are in the world, and welcome to Ubuntu on Air. My name is Jose, and I'm an Ubuntu member broadcasting live from Peru. Welcome to another Juju Charm School. Today we're going to talk about charm relations. So we've got George Castro, Benjamin Slaughter, and Matt Brosek. So, George, go ahead.
All right, we're live. George Castro. We try to do these charm workshops every few weeks, and the way it works is I send a list of topics that we think are going to be interesting for the Juju community, and then we go ahead and get feedback on what people want to see, what's confusing for them, and then we have a little hangout workshop where people can come ask questions, kind of understand what's going on here, and then we take all of these and put these on a videos page so people can figure out how to best consume Juju and write their own charms. So today's topic is going to be relations, and for this one we brought in Ben Saller, who he'll introduce himself in a minute, but the reason we wanted to bust this one out is relationships are pretty much the entire, I would like to say the entire reason for Juju existing. There's a lot of things that Juju does do, like automating, but the ability to connect two services together in a relationship is really where Juju's power comes from, and it's pretty unique to Juju. So we want to make sure that people understand this concept. We will be on #Juju on Freenode and on #Ubuntu-on-air on Freenode. If you want to ask questions, I'll go ahead and monitor the channel. And with that, Matt, why don't you introduce yourself real quick, and then hand it off to Ben, and then we'll get started.
Okay. I'm Matt Bruzek. I'm a Juju Charmer. I'm just here to help out and learn a little bit more about relations.
And I'm Ben Saller. I was originally one of the first authors on the Python version of Juju back in the day. I was one of the original authors of the GUI, and now I'm working in the solutions space to bring some of our platform as a service offerings and so on to the Juju community. So I'm going to go ahead and get started with this. We got a bunch of stuff to cover. We're going to be at a fairly high level today. But first of all, we just wanted to talk about what relations are and why they're important. George hinted at some of this in his introduction, but it's very important to understand that Juju is a language for talking about live service deployments in your organization. And in that language, there are two core concepts. One is services, which is the actual workload that we're talking about, be it a MySQL database or a web server or whatever. And then relations are the way that we talk about what information has to be exchanged between those services so that they can cooperate, so that they can function together. So there are a number of things to understand about why that's powerful in the Juju world, and then how to implement those, and what some of the best practices are. Relations are declared in the Juju world by editing the metadata.yaml file, which is sort of standard high-level description of any charm. And they have the capability to provide or require other services with interface. And this is relatively powerful because if we rely on this abstraction that's presented by interfaces, we can relate services that the original authors never knew would necessarily be related. So as an example of that, we can take a web application service and say that it provides an HTTP endpoint of a relation. And in front of that, we may be able to put, for example, a variety of HTTP accelerators or proxies that had no knowledge of this particular web app. And it's once you get that effect of many well-understood endpoints for relations and many things that can connect to them, you have a very powerful ecosystem of things to begin to work with. And that's Juju in a nutshell, and why understanding how these things fit together is so important. Does anyone have anything to add before I go on? George?
Sorry, I was muted. So if, just as an example, you mentioned HTTP, this seems kind of like a generic. Do people kind of tend to have agree what provides what, or let's say I have a cache that I don't know how that cache affects a certain web service, right? Um,
Yeah.
how does that work?
So you've quickly gotten to one of the sort of gray fuzzy areas. We have a competing set of desires in the Juju ecosystem. One is that the definition of what an interface is, a particular interface, is something that can evolve over time. If the kind and quality of data that needs to be exchanged in order to talk to a service changes because services grow more capabilities, we want to be able to capture that. But at the same time, we want that information to be discoverable and well documented so that there can be reuse, so that every time someone produces a new web application, they're more likely to use the HTTP interface than create their own custom one that can exchange a couple of additional keys. So there are these competing interests, and we'll talk a little bit about how those battle out. But the desire for organic evolution and the desire to congeal the ecosystem around particular interfaces and the definitions of what keys and values get exchanged over those relations is one that is still contentious and not quite settled. For example, as we describe interfaces in more details, it seems like it would be obvious that we could go to a web page in the ecosystem and look at what keys they are, what keys constitute an interface, what data needs to be exchanged, and yet that page doesn't exist. Currently, and this is, again, something that we'll hit in a little more detail, the best way to figure out what keys are exchanged in an interface is still to read code. And that's something that we're working to improve. And by the end of this talk, we'll cover one or two of the ways that we've tried to formalize that process and make it a little more digestible and a little bit more reusable. But that was a great question. Thank you. So I'm going to flip to an example metadata.yaml from a very simple charm that is documented. So this is from vanilla, and that's the hook. So let me bring up the metadata.
And vanilla is just a simple PHP web form, I believe.
Yeah. And so that's the metadata.yaml. This provides the highest level description of what the charm is. So yes, as you said, it's a forum, and it provides a HTTP interface, and it requires a MySQL database. So there's a couple of interesting things to note here. So for people that are familiar with Juju, you'll understand about how all the lifecycle events related to relations are implemented as a series of hooks, hooks in the hooks directory. Even to get started with Juju, you have to understand the very basic ones like install and start and so on, config changed. But when you create these relations, what we're doing is we're saying when I have new information to offer to someone that's interested in connecting to me, this is the way that I do that. When someone that I'm depending on, for example, in this case, the database, has new information for me, please let me know. And the way that Juju orchestrates that, the way that Juju lets you know, is by invoking a hook of a particular name. And that name is described by the information in this metadata file. So for example here, we can see that this requires a database interface, or a database relation with a MySQL interface type. And so what we're going to do is quickly hop over to the hooks directory, and we will see that there is a set of hooks, or a hook in this case, designed to deal with the database relation changed. So the database is the name of the endpoint in our charm, and relation changed is the event that we're responding to. And in this case, this is very simple. So hopefully, without too much explanation, you'll see what this is doing. There is a command available to hooks, and this is described in the documentation, but you can do a relation get on a particular key. So we're extracting from the remote end all of the information that we expect to use. And this is, in effect, what that interface is. It is that set of keys being exchanged under the name of the MySQL interface. So we get those keys, and if we have the information that we expect, we can continue, and down at the bottom we rewrite a config file and make some other changes to the system. But very often in systems like this, we expect these hooks to be called multiple times, and in most cases, not all of the things, not all of the keys that we expect will be present. And if that happens, the hook can just exit, make no change to its system, and we expect that Juju will invoke it again when the relation information is present, when something else is called relation set. And I want to show that as well in this very simple charm. If we go back to the metadata very quickly, and we say that it provides website HTTP. So we already know what the name of that hook will be. If we look in here, website relation joined. This could easily have also been changed, but we'll talk a bit about the life cycle. In this case, this is very simple. This charm just says when something is joining my relation, I want to push to it the information that here's the host name that I can connect on and the port. And that's all that it needs to provide that interface. It's implicit in the contract of that interface that that will be HTTP traffic. So are there any questions before I continue?
I have one.
Yeah.
So is there an expectation to be a matching set of relationship stuff on the other side? Like this is the web app bit.
Yeah. So again, we talked about the interface definitions being relatively informal, but they're not so informal that if you don't exchange the right keys, you can expect it to work. So something that consumes the HTTP interface necessarily will expect hostname and port to be set. And that's part of that informal contractual definition. The problem is, again, that contract is documented in code like what we're looking at here, and not necessarily well factored out into pages that are easily readable. And we do have some proposed solutions for that we'll discuss a bit later. But looking at this hooks directory, it's important to understand the life cycle that relations go through. So we talked earlier about the website is responding to relation joined. The database is responding to relation changed. There are that constitutes the bulk. Joined is typically called once when units of a service are first presented a relationship, they will have their join called. Changed is typically the more flexible hook, and that means that anytime someone calls relation set, that hook will be invoked on the remote side with the new values. And so that can be frequently invoked, and it can be frequently invoked in such a way that we expect it to silently not have all of the data and just exit, as I discussed before. The final one is relation departed, which is when the administrator does a remove relation. They're basically given, each unit in that relation is given a chance to say goodbye, to take any cleanup action. So that is the basic sequence of events. The important thing to understand is that these are not necessarily only called once. So relation changed, again, is typically called many, many times. And that goes back to the old thing that we like to say in Juju, that these things should be conceptually idempotent. Not in a mathematically pure sense, but that calling them repeatedly should produce no harmful effect, should continue towards the expected operating state, and shouldn't damage the system in any way, right? So if we look at a change...
Before you move on real quick,
yeah.
I just thought you should mention, I see a lot of charms with relation broken. Can you just spend a quick moment talk about that people do have an option to do things when stuff does break, when the admin doesn't explicitly mention?
Yeah, if machines go down or things are destroyed but the relation isn't explicitly removed, you also have a chance to clean up. It gets a little bit tricky, some of the failure modes that you have to deal with. I would suggest that the docs cover this in more detail than I was going to go into, but you're right that I did not.
I just wanted to mention that they exist for people that, you know, you don't just have these states, you have other options.
So, yes.
I have a question. So what happens if you ask, like, if your charm asks for information on the relation join hook, but it doesn't get it? Will it get it after that?
Well, if something calls relation set on the remote endpoint, it will eventually get a changed hook. So typically, a pattern that you'll see is that, with few exceptions, I mean, obviously there are things that you only want to do when you know the relation is joined, but it doesn't necessarily mean that the remote service can provide all of the things it needs for a client to use it. So what you usually see is that everything is done in changed, because anytime things change, you necessarily need to reevaluate the entire relation to that unit anyway, because we don't necessarily know what would have changed. We have to reconsider everything. And that typically just means rewriting a config file and restarting a service or something along those lines, but it could be significantly more complicated than that as well. So now that, is that a reasonable answer to your question, or are you looking for something else?
That was basically it.
Okay. Now that we've just got a high-level overview of what some of this get and set looks like, I want to talk a little bit more about what can go into the metadata .yaml. There are a number of things that we haven't covered yet. So if we look at these, the provides and requires, there are a few other things that are worth covering here. These provides and requires are two of the types of relationships you can have, and these are perfectly equivalent. From a Juju perspective, we don't particularly care if something provides or requires. It doesn't necessarily imply that you're a server or a client of something. It's an almost arbitrary distinction. There is one other class that's particularly worth noting, and that's peers. Peer relations are automatically established to units of the same type. So, for example, a REOC cluster, where every unit may have access to every other unit, or a Hadoop slaves that are all aware of each other from an orchestration level, might share a peer relation, and that has very similar lifecycle events, slightly different semantics, and plays into some of the more complicated things you'll see, like leader election and things that are in the Juju development pipeline. The other interesting thing to be aware of is a thing called scope, and you don't see that defined here. There's a key that's a sibling of interface called scope that would normally default to global, which is what all of these are. But there's also a thing called container scope. And for people that are familiar with subordinates, there is a relation that is scoped quite differently. So let's, for example, take a globally scoped relation like HTTP, and imagine that we have a proxy service, like an HA proxy, sitting in front of 4 units of a web application that's providing HTTP. In an example like that, every unit of the web application is able to exchange information with every unit of the HA proxy. That is globally scoped. They all get connected. The life cycles will be invoked in such a way that for every unit, there will be a relation change event when a key gets set. In contrast to that, when you're dealing with a subordinate, and as a reminder, the contract with a subordinate is, I am deploying a charm inside another charm, and I need access to its file system. This is typically used for things like logging agents or monitoring daemons that run alongside a primary service or principal service. And the way that that is managed is through a relation. We deploy the principal service, and we deploy the subordinate service, and we add a relation. But the scope of that relation, when it's a subordinate, is scoped to the container. And by that we mean the unit of the web app and the unit of the monitoring service. So if there's another unit of the web app, it's not exchanging relation data with something running in another principal, only the one that is scoped to its container. And in Juju, we've reserved the right down the road to explore what other kinds of relation scopes look like, but those are the primary ones right now, and worth understanding. So yeah, peer relations and scopes. Anything before I go on? No? Okay. So interfaces, we've talked about this, provide a set of keys. And those keys are the protocol. We talked a little bit about the handshake that these things go to, from calling when the relation is joined, and then when the data changes, and then whether it's broken or departed. Although in a typical life cycle, we expect that things are joined once and then typically not removed. That if you depend on the database, you depend on the database for the life of the application. That said, again, the change took may be called a number of times. I think it's probably worth looking at another to see the similarities and differences. This is another older charm that was simple enough that we could show. Here, if we look back at the vanilla charm, let me bring that back up with the relation hook. One of the nice things about this style is that if you look, all of the keys that we depend on, all the relation gets, are right up at the top of the file. So it's pretty easy to understand that. Here, this isn't any more or less readable necessarily, but you do sort of need to scan through the code to see what all the keys are on this interface. There are just a few different places that it's called, and they're only separated by a few lines, but it makes a difference when you're trying to say, what do I need to provide to be able to connect to that service? So, yeah. So this is a Node app, and this is the hook for its MongoDB relation change. So MongoDB exchanges different keys
Say
than.
Ben,
Yeah, sorry.
pardon my interruption, but we should talk about the private address and the public address. Those are implied ones. So those aren't keys that the relation is sending. Those are ones that are implied that you
Yeah.
get for free on a relationship, right?
Yes, that's a good point. Thank you. Yeah, Juju itself does insert public and private address. Depending on the cloud provider you're using, you may or may not have both. I mean, they may be the same. But for example, on Amazon, the private address would be the internal one, and that's typically what you want to share to other services running in that deployment as they're talking on the internal private network. But that if something is exposed and public, you would rely on its public address. And the private address is inserted into the relation implicitly. You're also able to deal with the public address through unit get and the public address. But yeah, those keys are there. One of the things that's not shown here, and one of the ways that relations are consumed, if you look at the help text for relation get, all of the relation get and set command, well, relation get takes a format flag, and you can have it output, I believe it's both JSON and or YAML. So what you'll typically see is that things will call relation get with a format JSON, and in some higher level language than Bash, like in a Python script, for example, and then they'll just process the JSON and have those keys in a dictionary for handling natively in the language that the charm is actually implemented in. We've tried to select hooks that were written in Bash just to show today, as it's typically a little simpler to get started. It's worth noting that because relations are such an important concept in Juju, that the handling around them, as the charm becomes more reliable, more dependable, typically of higher quality, they do tend to get a bit more complicated than just the simple exchange of keys. I was going to show, for example, the Postgres charm, which is a very nicely done charm, but the file actually containing the hooks is, I think, over 600 lines of Python. And there are interesting reasons to go why that happens and what it means to actually become robust. But at the same time, we have frameworks, one of which I'm going to highlight in a bit, that drastically reduce the amount of infrastructure that you're responsible for implementing in order to get sort of robust, sophisticated relationship handling. Okay, so one of the motivations for wanting to show the Postgres charm, and I don't want to get into the code itself, but we talked about the problem of documenting interfaces and how do you figure out what keys need to be exchanged. While the implementation itself is relatively, we go down through the README, they've actually gone through and described all of the keys that get exchanged in the various relations, and that pattern is very useful. We're looking for ways to harvest that information and produce a website, even if it's as simple as a wiki, that sort of just outlines what keys belong to what interfaces so that people can agree and reuse these things more easily. But that is not the state of the world today. Does anyone have anything? I'd like to go on and just highlight the services framework as an example of trying to do relations. Okay, I'm gonna.
Before you go on, yeah, I wanted to ask a quick question about relations if you have multiple nodes. So let's say you have 3 WordPress nodes in just one MySQL instance. Will the information replicate to each node, so you can like just go ahead and use the HA proxy and you'll have the same information in the 3 WordPress nodes?
Absolutely. The default, again, is a globally scoped relation, which means that all of the information is shared. Everything will have its, when the HA proxy or whatever in the example sets it's something on its relation, everything connected to it gets its relation changed, invoked appropriately. And that is indeed part of the magic of the system. So yes, there's some replication of keys. Things may be called more times than you would sort of expect, but because of that, everything gets all the information and everything can proceed, for the most part, only having to rely on its own view of the world. There's some interesting things also that I didn't talk about in terms of implementing hooks, like if I call relation get here in this, and then I call it here, is there a chance that the world has changed between those calls? Like, could I call private address, but the units had its private address regenerated or changed during a hook invocation? And the answer is no. Juju takes care of making sure that you get one world view for the hook execution. You can go in and call relation set as many times as you want before the hook exits, and there will only be one block of data and one hook invocation, regardless of how many times you do that thing. As a result. Now, I say one hook invocation, but back to your point, it would be one hook invocation per connected unit. So it's going to be called many times, but not 4 times the number of units. If you called relation set 4 times and there were also 4 units, that would get very expensive. Okay, does that cover it? Yes, no, maybe?
Yep, basically,
okay.
Basically that was that.
Okay. So in the space that I've been working on, we have a pattern for dealing with large, complicated systems where the number of relations between services isn't 2 or a single pairwise thing, but where services may be highly interconnected with 3 or 4 different kinds of relations. Each service is probably connected to 5 or 6 other services, some of them multiple times on multiple different interfaces. In systems like this, it gets very complicated to know when you can and can't take action. So we have this thing that's in Charm Helpers, and if you're not familiar with Charm Helpers, I'm sure that there are talks to get you started with that. But this is a relatively new addition to Charm Helpers called the Services Framework. And it does what I like to call a semi-declarative structure for hooks. And this is one of the ways that we try to get around some of the problems of how do I robustly implement relations, and how do I understand what keys are exchanged as part of my interface. And so this is the high-level view of what charms look like in this framework. Just to back up, this is an example charm where we ported some of the code to this framework. So just so that we're familiar, it provides a website, HTTP, and it requires MySQL. So this isn't that different than some of the other charms that we've looked at today, but the implementation here is quite a bit different. These are all small, very small files. So if we look at changed, all it's doing is importing that service definition block and calling manage, and they all look like this. So it's very simple, and then to understand what the charm is doing, we only have to look here. So here, there's a number, each of these defines some of the default policy for interacting with the framework. What data do we provide? It provides an HTTP relation, and there's a helper class for that. And we can go into that in a little bit more detail. But and it provides required data. So these are required config. Hopefully that's readable. So in the service config for this charm, there's domain and password. In the relation space, though, we depend on the MySQL relation. And the MySQL relation helper class already defines all of the keys in the MySQL relation. So it knows what it depends on. And then we have a stored context of some other secrets that we generate and make sure that are only generated once and shared around. But the important thing here is the MySQL relation. So the helper class is a way of capturing a definition of what keys need to be exchanged on that interface. And the services framework will go through and say, if I have all of those keys, if and only if I have all of the things in my required data, then I can execute this data ready block. And this data ready block will do things like re-render the configuration templates, and that's with all of the context that was in the required data. Re-renders another configuration template here, calls some custom code to initialize our database, create the tables, create an admin account, and then it will restart the service. And in this case, the service is Apache 2 managed by an upstart job. And that's just a step that's, while documented in the framework, is sort of implicitly tied to the name of an upstart job right now. It's completely overridable what that behavior is. But what we're looking at is that this pattern of declare everything you depend on and only take action when all of that met is what many of the more complicated charms are actually trying to implement in their relation changed hooks. The issue with the way that those do it is that those relation changed hooks are scoped to a single relation. So if you depend on both having an HTTP accelerator in front of you and a database behind you before you want to say that you're ready to start your service or take action, you would need to coordinate somehow between your individual hooks, because you're only going to know that one side changed and then the other side changed. The services framework rolls all of that into one concept where you would just list both of those in your required data and hang actions off of it. So if you're doing anything that's even slightly complicated, I would very much recommend looking at this pattern. You get a whole lot of nicety, a much simpler structure. And when you go through and you look at the helpers and the provided relations, there already exists what we call relation context for many of the common services, including HTTP, including MySQL, and some others. And those serve as building blocks for filling in the gaps for things that are custom to your application. So again, that's in Charm Helpers. It's in core. There is the service manager. Highly recommend that you look at it. Does anyone have anything else to add?
Yeah, have we thought about maybe perhaps being a little bit more opinionated as far as pushing the services framework?
So
I'm going to venture into like a little bit of policy and what people should be doing, kind of like.
Well, it's an interesting point, right? We review, and as reviewers, we're exposed to all kinds of styles and all kinds of different hook implementations. People write hooks in Bash, they write them in Python. We like the services framework for a variety of reasons. One is you get that robust implementation, you get that blocking pattern of only taking action when everything is ready. But also, this is pretty simple to review. We can see at a glance what the structure of the charm is, and if you're familiar with the framework, it makes digesting easier. So to answer your question, can and should we push it? I think that we should. We still want to allow the ecosystem to evolve. This doesn't have to be the end-all, be-all of charm authoring, but it is a great place to start. And so some of the changes that you'll see in the future are that the Charm Tools provides a template generator, and one of the default templates that we're going to be including, I believe it's already there today, but that will be reflected in the documentation and the getting started with charm authoring will be a template around the services framework. So in that sense, we're going to be pushing that more. In all likelihood, it means that your code will get reviewed more quickly because there's a lot less variance in the charms when all of the hooks link to this one block definition, and we know that the relation code is shared with other projects. And all we really need to look at is the actions that you take in data ready, are those appropriate?
Sure.
Right.
And it sounds to me like you feel when it comes to mass, something as complex as Cloud Foundry, right? Kind of have to, don't you?
With Cloud Foundry, I think that we don't have a choice.
Right.
You need some kind of framework. The amount of interconnection between services, as I hinted at before, is very high order. And so we would necessarily have to consider the state of many risks before we can take action. So we wrote this framework to deal with that.
Right. Makes me kind of wondering to see how this would maybe match to see what the have we had the OpenStack Charmer guys look at it? I'd be interested in seeing them having something as complicated for so long.
OpenStack was our first set of very complicated charms that had to work as a cohesive whole, and we learned a lot doing those. That team did some really great work, and some of that is the precursor to the services framework. What we have today in the services framework is what I would consider a more mature, more flexible, and slightly less opinionated way of dealing with some of the issues that they had to come up with. So we refactored a lot of what they had. We expanded on it. They have seen this work and are interested in it. Okay. The time it would take to move the entire project to that is uncertain. But we have assurances from the development leads on those projects that any forward work that they do will probably use this. So that would be OpenStack and Cloud Foundry, some of our bigger projects, both using this, which is very encouraging. What we're able to show with the Chamillo charm that I've been going through is that it scales down very well.
Right. So individual authors will just pick and choose, snag the parts that they need.
Yeah. So, even one of the interesting things here is that when we provide the HTTP relation, it knows what keys to get. There's some interaction with the port that we've defined. It knows when data ready that it should automatically expose that port. It knows that when data is not ready that it should close that port, that it's no longer an accessible service. So the framework itself has a bunch of defaults, which are, again, overridable and documented. We actually, this is one of the better documented pieces of charm helpers today. Although the documentation of the whole project is improved, this is something that I think is easy to follow and easy to understand. So, yeah. There's obviously a lot that can be done with if we look at some of the comments, things get quite verbose. This deals with all of that complexity in a very manageable way. So to anyone that is either struggling to implement things to make them digestible or trying just to figure out what the right pattern is, this is our current recommended best practice. So, yeah. And we're always happy to field questions about it because we're excited to see it get more use in the real world. Any other questions? All right, if nobody has anything else to add and there are no questions, I think that that's plenty for people to investigate.
Mm-hmm. Yeah, let's just give it a few minutes. So is there anything you want to say in conclusion there, Ben, before we wrap up?
Attempt to reuse interfaces as much as possible, wherever possible, because it allows people to connect your charms and services to things that you may never have anticipated. Every time you have to go off and make something custom, think about making as much of it as common part of an existing interface and an existing relation, and put your custom keys into something else. so that at least the core part of the service is reusable. That's where we derive a lot of power in the ecosystem, and it makes everyone's work in this space better. So that's I guess my parting thought.
Okay. All right. So it sounds like we pretty much covered the subject in depth. Thanks very much, Ben, for running the Charm School. I'll go ahead and we'll wait for the video to render on YouTube and send out the links and everything out to the mailing list. If you have subsequent questions, feel free to just reply to that thread on the mailing list, and we kind of keep an eye on the YouTube channel as well if you have any questions on the things that we've talked about here today. With that, thank you for joining us at Ubuntu On Air. Our next session is, hold on, I forgot to pull the calendar up. Sorry. I believe November 15th, so we've got a while.
In 4 weeks.
4 weeks. Yep.
Yep. It's in November the 21st. It's going to be about debugging hooks.
There it is. Yes, debugging hooks. That's going to be me, Chuck, and Marco probably. So thanks. You have the calendar up way faster than me. So with that, thanks everyone, and we'll see you next time.
Yeah, thanks. Hope that was helpful.
Make sure to subscribe to the Ubuntu On Air YouTube channel at youtube.com/Ubuntu On Air, and follow us on Twitter at twitter.com/Ubuntu On Air. We'll be posting constant updates about our sessions in there. So thank you for tuning in, and make sure to later.
See yous.